Okay, welcome students. Today we're going to learn Notes 11.7, which is geometric probability. And we're going to start by reviewing some vocabulary terms, and we're going to start with the definitions, and then I'll tell you what the vocab word is. Here it says a measure of the likelihood that an event will occur. So that's, what is the chance of it happening? Well, the vocabulary term that we use for that is probability. Okay, and then here we take it a step further, and if we have a ratio that involves a geometric measure such as a length or an area, then we're going to call that a geometric probability. Okay, so here, let's start off with probability and length. We're going to let this segment AB be a segment that contains the segment CD. So if you look over here, we've got this segment AB, and inside this segment contains CD. And then we're going to ask if a point K on AB is chosen at random. So anywhere in between point A and B, we're just going to throw a dart and pick a spot. And if it's chosen at random, then the probability that it actually lands on CD is the ratio of the length of CD to the length of AB. So let's write that over here. So the probability that K will land on CD, like if you throw a dart and pick a spot, then it will be the length of CD, segment CD, over the length of segment AB. Okay, so now we can also relate that, that's when we're talking about length, linear measures, but we can also relate it to area. So probability of area is let J, see, J is this region over here, contain region M, so there's a separate region inside here. If point K in J, so if point K, if I throw a dart and it lands somewhere in here, in the shaded area, is chosen at random, then the probability that it is in region M is the ratio, that's supposed to be ratio, of the area of M to the area of J. So the P, so the probability of this event here, K, is in region M. So if we throw a dart, we know it's going to land on J, but what's the probability that it actually lands in M? So we're going to say area of the favorable outcome, which is M, over the area of the total, which is J. Okay. So now, let's do some examples. All right, first, find the probability that a point chosen at random on FJ is on GK. So here, I'm going to write the probability of the event. So what event do I want? I want a point to land on GK. So that's my favorable outcome. That's what I want to happen. Okay, well, in order for that to happen, I need to find the length of my favorable outcome, so the length of GK, and place it over the length of the total. And the total would be of, it said, of FJ. So those are my boundaries. It's got to land in between F and J. Okay, well, I'm going to count the spaces. So here, GK is going to be 1, 2, 3, 4, 5, 6. So that means that GK goes from here to here. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 units long over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long Always reduce your ratios. So that's going to be 3 over 4. So my probability of this event occurring is 3 out of 4 chances. Okay, chances, we can rewrite this ratio as a decimal, and if you plug that into your calculator, we know it can be rewritten as 0.75. Sometimes you'll see probability written like this, and a lot of times if you think about batting averages, that's what this is talking about. We'll see batting averages, or sometimes we'll see stats in the paper written like this. Another way is for people to think of probability is what is the chance of that's going to happen, and some people think about it in percent. So that's a 75% chance or a 75% likelihood that that event will occur. So when we think about probability, this is usually how we see our answers here this way. So that's probability. And then when we think about chance or odds or chance, we think about them as decimals or percents. All right, next. A shuttle to town runs every 10 minutes. The ride from your boarding location to town takes 13 minutes. One afternoon, you arrive at the boarding location at 2:41. You want to get to town by 2:57. What is the probability you will get there by 2:57? Well, before we start looking at this, you can look at the timeline. And what we want to ask ourselves is, find the longest time you can wait and still arrive on time. So I want to get there by 2:57. And it takes 13 minutes for the bus to run. So if I subtract 2:57, 13 minutes away from 2:57, so that's going to be 2:57, take away the 13 minutes that it takes to run, that's going to be 2:44. So I need the bus to be there by 2:44. Well, if I get there at 2:41 and I need the bus to be there by 2:44, then that means I can only afford to wait for 3 minutes. So step 1 was to find your wait time. Okay, the longest wait time that you have. And that's going to be 3 minutes. That's my longest wait time that's possible. Okay, step 2. In step 2, you know that the shuttle will arrive, since it runs every 10 minutes, the shuttle's going to run, and it should arrive within 10 minutes or less. For example, if I get to the bus stop and the bus takes off as if I'm walking up to the bus stop, that means I'm going to be waiting 10 minutes. But if I get to the bus stop and I don't see a bus, I'm hoping that the bus is going to get there within 3 minutes. Okay, so this shuttle is going to arrive somewhere between 10 minutes or less, but I need it to be, but you need it to be there within 3 minutes. Okay. So, the probability of getting to town on time, get to town by 2:57. Okay, so the probability of this event happening is going to be the favorable waiting time over the maximum wait time. Okay, well, the favorable wait time we know is 3 minutes. The maximum is 10 minutes. So this is my probability of getting to town on time. So probability of get to town on time is 3 out of 10 chances. Well, if you take that and translate it to chances, that's percentage, we have a 30% chance of arriving on time. Odds are not really good that you're going to get there on time. You probably should have shown up to the bus stop a little bit sooner. All right, next. Okay, the next one we have, a golf ball is hit and stops on the green. This right here, this big circle, that's the green. A prize is won if it stops in the painted circle, the teeny tiny painted circle. The diameters of the green and the circle are shown at the right. If the ball is equally likely to stop on any point on the green, what is the probability that a prize is won? Okay, so let's write down the event. What is the probability that we will win a prize? Win a prize. Okay, well, that's going to be the area of the small circle, which is the painted circle, over the area of the large circle, which is the green, which is what we call the green. Well, area of a circle, remember, over here to the side, area is pi r squared. And we know that the large circle has a radius of 75, I'm sorry, not radius, a diameter of 75 feet. So that's the diameter. And its radius happens to be 37.5 because you cut that in half. Now the small circle, its radius is diameter is 15 feet. So cut that in half, the radius is going to be 7.5. Okay, so what is the chance that we're going to win? What's the probability of winning? Well, we've got to do pi r squared. So that's going to be pi 7.5 squared over pi, and that's going to be 37.5 squared. Okay, so if I just plug these numbers into my calculator here, I'm going to get 56.25 pi, remember you write the number in front of pi, over 1,406.25 pi. Okay, now what happens to pi in both of those? Well, you should know that they cancel each other out. So this is all you have to plug into your calculator. And remember, you're going to put 56.25 divided by 1,406.25, and then remember to hit the math key and enter it twice so that you can reduce that fraction, or change that decimal back into a reduced fraction. And when you get there, you're going to see that it's going to reduce to 1/25. So the probability of winning a prize is 1 out of 25 chances. So what if you change that to a percent, that really means, which is a 4% chance of winning a prize. Okay, so that's a 4% chance. So here's my probability, and that's the meaning of it. That's what it means. All right, almost done. A homeowner's property is shown in the scale drawing. We have lakefront property. Here's my grass, and there's the water. If a deer is equally likely to be anywhere on the property, estimate the probability that it is actually on the grass, standing on the grass. Okay, so for step 1, I want to find the area of the grass. The favorable outcome is the deer standing on the grass. So I want the area of the grass. Okay, so if I count, this is 1, 2, 3, 4. And I'm just going to draw these in so you can see them. Just kind of take a straight edge if you want, and just kind of connect these dots, and then straight across. And what you're going to do is you're going to count squares. Okay, so here that's going to be 1, 2, 3, 4. That's a 4 by 1, 2, 3, 4, 5, 6, 7, 8. 4 by 8. Almost a 4 by 8 rectangle for the grass. So that's almost 32 units squared. Okay, now the next one is the total area. Step 2 is going to be total area, which is going to be the grass plus the water. Okay, we already know that the grass is 32 units squared. So now I just have to count out the water. And if I look, that's going to be 1, 2, 3, 4, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, almost 11 squares. And then this one is almost 1, but I can take like some of this piece over here and add it right there. So that makes 1 more. And then here, this piece here, that makes 2 more. This more of this can add here to make 3 more. And then this piece right here could add here to make 4 more. So I'm going to add plus 4 more. Alright, so if I add all these up, this is going to be 43 plus 4 more, which is approximately 47 units squared. Okay, so now step 3 is to write my ratio. So that's going to be probability of the deer on the grass. Okay, so that's going to be the area of the grass over the area, well actually total area, I should write total. Okay, now that's going to be 32 over 47, and when you try to reduce that in your calculator, it's not going to reduce. So that is my probability. But you can
Norma
take
Ojeda,
that.
please come to the front office. Norma Ojeda, please come to the front office.
You can take this and change it into a percent, and if you do that, it would be about 68.1%. Okay, so that'll give you a little bit more understanding of what we're talking about. So there's a good chance that the deer, if it's standing on your property, it is actually standing on the grass. All right, folks, that's it for our notes. 11.7.